Hi everyone, this is Hina and I welcome you to session number 3 of ISTQB Test Automation Engineer Certification. So in our last session, we covered the first part of first module, which was purpose of test automation. In today's session, we will be covering success factors in test automation. So let's first have a look at what are success factors. So success factors can be like any factor or elements that are necessary to achieve a goal. And in this case, our goal is test automation. So major success factors for test automation include test automation architecture, also known as TAA, SUT testability means system under test testability, test automation strategy, and test automation framework, TAF. So please make sure that you are aware of all these acronyms because these acronyms will be used continuously throughout this syllabus. Okay, so now these are the major success factors. Now let's have a look on each and every of them in detail. The first one is test automation architecture. So what is automation architecture for testing? It provides an architectural overview of the test automation solution, which is also known as TAS. So it gives us an overview of what are the components of a test automation solution. Like it can be components, it can be layers, it can be services or interfaces, etc. So let's say that we have our system under test, and every system under test will also have an architecture. Now, for our test automation architecture, it's really important that it's aligned to the system under test architecture as well. So whatever the architecture is for our application, which will be testing, that system which will be testing, our test automation architecture should address the specific requirements for that system as well. So it needs to be aligned to that. And the test automation architecture should also address these quality attributes, which are maintainability, performance, learnability. So maintainability, that the ease with which it can be maintained, and this is something which we'll discuss in detail in this session. And the second one is performance, which means that what's the speed, efficiency, the consumption of resources, for example, power, RAM, its capacity, etc. And the third one is learnability. So learnability is the capability of any product to enable the user to learn how to use it. So these are the quality attributes which we definitely need in a test automation architecture, and more details of these quality attributes which are a requirement are also specified in ISO IEC 25000-2014, which actually provides the guidance for software quality requirements and evaluation. So for this syllabus, you just need to know the name of the standard. You don't need to go in much detail, so this much is enough. It is also helpful to involve software engineers who understands the architecture of SUT. So definitely the developers who have been working on the SUT, they are more familiar with the architecture of that. So it's really helpful if you coordinate with them, so that then you are in a better shape to understand and come up with the architecture of your test automation. Second one is SUT testability. The SUT needs to be designed for testability that supports automated testing. So if the SUT is not easily testable, then it gets very difficult to automate that system. So we can take few examples. Let's say GUI testing, graphical user interface testing. SUT should decouple as much as possible the GUI interaction and data from the appearance of the graphical interface. Okay, so what is decoupling? So decoupling is the process of splitting the application into smaller parts, like smaller components. And as smaller components or individual components there would be in SUT, it will be easy to automate, and not only easy to test and automate, but it will be easy for the application to be changed and maintained as well. The second point is API testing. More classes, modules, or the command line interface needs to be exposed as public so that they can be tested. Okay, so when we talk about API testing, if they are classes, modules, or CLI, then that needs to be public because it makes it easier to automate. And otherwise what happens that then devs can help to mock objects. So like we studied stubs in foundation level. So yeah, so then devs can help to mock objects that simulate all the dependencies and access to the private APIs directly. But of course that would be quite challenging. So it's always easy if all these classes or modules are exposed to public, it can be easily automated. Number 3, the testable parts of the SUT should be targeted first. Generally, a key factor in the success of test automation lies in the ease of implementing automated test scripts. Exactly. So if there is a system under test, it's very important that first you identify that which parts we can automate, which parts we can't automate. So let's go first with the parts we can easily automate, and then the ones which we can't automate, then see that how we can automate, or maybe it's not even worth it. Maybe it's not even necessary to automate the rest of the parts. So that's why this is a very important key factor for the success of the test automation, to go first with those parts to automate which can be easily testable. The third one is test automation strategy. Okay, so test automation strategy is a high-level plan to achieve long-term objectives of test automation under given conditions. So just like we have our test strategy usually when we are performing testing, then similarly we also have a test automation strategy as well. And what it does is that it defines test automation goals for critical areas and to obtain cost and time benefits wherever possible. A practical and consistent test automation strategy that address maintainability and consistency of the SUT. So the test automation strategy should be addressing things like that, how the test automation should be easily maintainable and consistent. And throughout we will be focusing a lot on these factors because this is a very important factor to identify whether test automation will be successful or not. Over here, the examples we can use are reusable scripts, reusable test data, or if they are coding standards. So all these things, it makes the test automation code easy to maintain and consistent. When creating the automation strategy, consider the cost, benefits, and risks of applying it to different parts of the code, both old and new parts of the SUT. Okay, so there is a system under test, and of course there is a specific functionality of that system under test, and then later on there are some changes to the SUT. So they are like old and new parts. That's what it is referring to over here. So now our test automation strategy should address this, that how it can be applicable to both old and new parts of SUT. It shouldn't be the case that if there are lots of changes in SUT, then we are spending a lot of money on that. So that's why it says that consider the costs, benefits, and risks, because it might be that if we are applying it to the new parts of the SUT, it might be very costly and not beneficial, or it might be that it is costly but it is more beneficial with low risks. So it's just a balance of cost, benefit and risk, which needs to be addressed in the test automation strategy. So that's why it is very, very important. Both user interface and API should be considered for automation testing to check the consistency of the results. So if you are testing any specific system and it has both APIs and graphical user interface, then it's quite beneficial that you are automating both UI and API, because what you can do is that you can compare the results and you will get more assurance of the consistency of the results from both API and the graphical user interface. The last one is test automation framework. So test automation framework is a tool that provides an environment for test automation. So we can also use already built frameworks for test automation. There are so many tools which we can just start using for test automation because the framework has already been there, or we can also build a framework for test automation from scratch as well as per the requirements. So there are many options for that. So a test automation framework that is easy to use, well documented and maintainable supports a consistent approach to automating tests. So test automation framework, the selection of which framework we will be using for test automation is very, very important. And the reason is because sometimes we get to hear about a tool, we just get the license of that and we start using it without understanding that is this something appropriate for the project which we are using this tool for, or if we are building our own custom framework, then there are many things which needs to be taken into account of rather than just start coding and automating the test cases. So it should be very easy to use. It should be well documented, because if it's well documented, then it's easy to maintain it as well, because it's very easy to start using any framework, but then in the long run we get to know about the limitations, that it's not easily maintainable, it's not easily scalable, and that's why at many places test automation fails, it's not successful. In order to establish an easy to use and maintainable test automation framework, the following must be done. Okay, so now let's see that what we have to do. First of all, implement reporting facilities, enable easy troubleshooting, address the test environment appropriately, document the automated test cases, trace the automated tests, enable easy maintenance, keep the automated tests up to date, plan for deployment, retire tests as needed, and monitor and restore the SUT. So whenever you are designing a test automation framework, or if you are using any already built framework, a test automation framework, you are using a tool, so it's really, really important that you consider these factors and then see that how it applies to your project. Because if you spend some time in the beginning of the project and in the selection of the test automation framework, then later on it will be very easy for you to maintain that framework. Okay, so now let's see all these things in detail one by one. The first one is implement reporting facilities. So just like in manual testing, when we execute our test, then at the end we also report, we also maintain a test report, that how many tests were failed, how many were blocked, how many are not executed. So similarly for test automation as well, a reporting facility is very, very important. So there are many ways to do that. If you are working on, let's say, C#, Selenium, then you can use extent reports, or there are many test management tools which, along with manual testing, it also supports automated testing as well. So if you link it to your scripts, then it also take care of the reporting facility. So you can also generate the report for your automation testing as well within that test management tool. So there are so many ways to come up with the reporting facility. Now, why this is important, just like for manual testing, these automated test reports are also important for just informing your other colleagues that what is the quality of the system, to keep them informed that about the test metrics, etc. And this involves the testers, test managers, developers, project managers, and other stakeholders. Second one is enable easy troubleshooting. Okay, so whenever we are running automated test, of course, all the tests will not pass. They will fail as well. But it's really, really important to be able to analyze that why that test fail, and that's why troubleshooting needs to be very easy. So test automation framework needs to provide an easy way to troubleshoot failing tests. The test can fail due to failures found in the SUT. So the system you are testing, there can be defects in that. That's why maybe the tests are failing. Or maybe the test automation solution you have developed, there are issues in that. Or there can be problem with the tests themselves or the test environments. So you must have noticed that many times one test is passed on a specific environment, but as soon as you run it on another environment, the same test fails. So that's why there can be many reasons why a test have failed, and it will be easy if you have that troubleshooting an easy troubleshooting way to identify the cause of the defect. So for example, you can also, whenever there is a failed test script, then you can add a capture that which capture the screenshot and of the error message, and also give you the details of that which line of code actually failed, so that you have that all in the log, and then it's easy for you to identify the real cause of the failure. Number 3, address the test environment appropriately. Dedicated test environments are necessary in automation testing. If there is no control of the test environment and test data, the setup for test may not meet the requirements for test execution, and it is likely to produce false execution results. Okay, so for test automation, it is very important that we have a separate dedicated test environments, because let's say that if you have a single test environment which you are using for both manual and automation testing, and you have specific data which you have set up for test automation, but because you are also doing manual testing in the same environment, and there are builds which are being deployed very, very frequently, it might conflict with the test data and the other things which you need for your test automation, and which will result into false execution results, which means that maybe the test will fail, but actually it failed because of that test environment issue rather than an issue in the system under test. Number 4, document the automated test cases. Test automation goals need to be clear and documented. For example, which parts of the application are to be tested, to what degree, and which attributes need to be tested, both functional and non-functional. Okay, so it's very, very important that we document the automated test cases as well. It doesn't mean that we create like a Word document, a detailed document for that, but there are many other ways to do that. There are many other ways to plan or organize your test scripts in a way that they are aligned to your test cases or to the requirements requirements, so that it's very easy to identify the link between the requirements, test cases, and the test scripts as well. And it's easy to maintain as well. And later on, if there are any kind of changes as well, you can just directly go and change the specific test case, test script, because you know that only this part has been changed. So that's why documentation of automated test cases and keep it updating is really important. Number 5, trace the automated test. Support for test automation engineer to trace individual steps to test cases. Okay, so what does that mean? That just like we studied a lot about the traceability in the foundation of different, like from test cases to the requirements, etc. Similarly, like that, over here in automation testing as well, traceability is of key importance. So it's very important that the test automation engineer has the support, has the facility to be able to trace the individual steps in the test scripts to the test cases. Because let's say that if the scripts are aligned to the test cases and the test cases are traceable, we are able to traceable to the requirements, then if there is any change in the requirement, then you can trace it back to where the changes need to be done in the test script. 6, enable easy maintenance. Automated test maintenance should not consume a significant part of the test automation effort. Yes, that's true, because we don't yes, maintenance of automation test is a time consuming activity, but still it needs to be done in a way that it's not just taking all of your time and you have to put a lot of effort, even more than required. The maintenance effort needs to be in proportion to the scale of the changes made to the SUT. So the system under test, of course, when we do any kind of changes in the system under test, then of course, if the changes are there, then we have to do some changes in our automation test code as well. So this says that it should be the time you or the effort you put in maintaining the code, it needs to be in proportion to the scale of the changes which made in the SUT. So it shouldn't be like that if there is a very minor change which took, let's say, 1 hour to make that change, and then you are spending 7 or 8 hours in the automation framework to make those changes in order to maintain that code. So it has to be in proportion. To do this, the test cases should be easily analyzable, changeable, and expandable. Yeah, so that's true. So our test automation framework, it needs to be designed in a way that maintenance is very easy, because that's where the automation frameworks fail, because it's easy to start, but then it's difficult to maintain and scale that framework. Because of course, if you are coming up with a framework and you have limited tests, it will not always be the same. As you start using it, as you start progressing with the development of the system, of course the code, that automated test will expand as well. So it should be easily analyzable, easy to change, and easy to scale expandable as well. Automated test where reuse should be high to minimize the number of items requiring changes. So yeah, that's true as well. So if there are any reusable scripts, that's like highly recommended, because instead of changing the scripts at multiple places, you can reuse the test scripts. And the same goes with the test data as well. Instead of like hard coding the data, you can use variables, you can add parameters, so that the test data can be reused as well. The next one is number 7, keep the automated tests up to date. When new or changed requirements cause tests or entire test suites to fail, do not disable the failed tests. Okay, so this is a very common behavior that if we are changing any, so let's say that there are some changes in the system, and we haven't updated our automated tests yet, and when we are running our tests, so let's say we have 10 scripts. So when we are running them, let's say 2 of them have failed. So what we do, that instead of updating those test cases, we just disable them, that okay, these should be skipped, and it's fine, we can come later and update that. It shouldn't be the case. We need to keep the automated tests always up to date, because only then we can ensure that we are testing the changes and the new requirements in the system effectively. Fix them. Yeah, that's what it says, that don't disable the failed test, actually fix them, update them. Number 8, plan for deployment. Make sure that test scripts can be easily deployed, changed, and redeployed. So just like we plan for continuous integration and continuous deployment for a system, for an application, the same applies for automation as well. So the same, we can use the same deployment tools, the same approach, just like for the code for this system. Number 9, retire tests as needed. Make sure that automated test scripts can be easily retired if they are no longer useful or necessary. So as the system will evolve, new changes will come. Of course, there will be lots of things which will be obsolete, and the same goes for the automated test as well. So it's necessary that we are frequently reviewing, and wherever the test, we know that these test scripts, we will not be using it anymore because maybe the functionality has completely changed. So in that case, just retire those tests, don't use them anymore. And the last one is monitor and restore the system under test. SUT must be monitored continuously to run a test case or a set of test cases continuously. If the SUT encounters a fatal error, such as a crash, the test automation framework must have the capability to recover, skip the current case, and resume testing with the next case. So what does that mean is that if you have 10 test cases and you have to run them in a specific order, then, and let's say that the second test case has failed for any reason, then it shouldn't be the case that you are not able to run the remaining test case. So your test automation framework should have the capability that if the second test case has failed, then fine, then just mark it as failed and then just continue with the rest of them, rather than just exiting and terminating the automation test right over there. So what's the next one? The next one we are talking about is test automation maintenance. The test automation code can be complex to maintain. Yes, this is one of the key challenges in test automation. We can see a lot of benefits in test automation, and there can be lots of challenges as well, and this is one of the greatest challenge, and that's why you will see that continuously there is a lot of emphasis on the maintenance of test automation. It can definitely be complex to maintain test automation. It is not unusual to have as much code for testing as the code for SUT. This is why it is of utmost importance that the test code should be maintainable. So just like we are doing development for system under test, test automation is just like that, because we are putting the same kind of effort as for the code for the SUT. And for test automation, the code can be similar to the code which we have for SUT as well, only like the objectives would be different for both development and testing. But it's not very unusual that we have the same amount of code for test automation as we have for the SUT. So that's why it's really important that we are able to maintain that test code. This is due to the different tools being used, the different types of verification that are used, and the different testware artifacts that have to be maintained, such as test input data, test oracles, test reports. So first we said that it's difficult to maintain. We know that why it's difficult to maintain, because the amount of code can be similar to as the amount of developments, which means it can be huge. And on top of that, when we are using test automation, we are using multiple tools, and we have to be considerate of like how the multiple tools are compatible with each other, and also with the system and the test what we are using, and there can be different types of verifications as well. And of course there can be a lot of things which we need to consider in terms of the artifacts, like the data which we are using for testing, and what about the oracles and the test reports, etc. So there are lots of key factors which makes the test automation maintenance complex. Test automation maintenance don'ts. Okay, so far we have seen that, okay, now test automation maintenance is complex, but it's really important. Similarly, now we need to know about few don'ts about the test automation maintenance. So do not create code that is sensitive to the interface. That is, it would be affected by changes in the graphical interface or in non-essential parts of the API. Okay, so this is, I think, the main pain point which usually we come to see in automation, and this happens mostly if it's not planned well in the beginning. So let's say if there are changes in the interface, then even if it's like a slight change on the interface, of course we have to make the change in our code as well for test automation, otherwise that script will fail. So that's why it's very important that we plan our framework, we plan our test code in a way that it's more associated to the behavior rather than associated directly to the graphical interface, so that if there are changes in the graphical interface, then we don't have to put a lot of effort in the maintenance of that test automation code. The second one is, do not create test automation that is sensitive to data changes or has a high dependency on particular data values, for example test input depending on other test outputs. Okay, so the same goes for the test input as well. So I just mentioned that we shouldn't be using hard-coded data, because if we are using that, then like whenever we have any change, then we have to go each and every place we are using that test data. So it's very important that our test automation, how we are defining our test input. So the variables is the ideal thing, because whenever you have a change in the in any test data, you can just go and change it at one place, and wherever that variable is called, is used in the automation code, then it will just use that input which you have changed in one place, rather than each and every place where that variable that test data needs to be used. Do not create an automation environment that is sensitive to the context. For example, operating system, date and time, operating system localization parameters, or the contents of another application. In this case, it is better to use test stubs as necessary, so the environment can be controlled. Okay, so the test, when we are writing our test automation code, as we already discussed, that we can use the same test scripts on multiple environments as well. And Yes, when we are using the same test cases, the logic would be the same, but of course the data would be different, the setup would be different, the configuration would be different for each test environment. So that's why we should avoid in our code that where we are using all the specific context in maybe hard coded in for all the environment related things. So instead we should just use the environment variables and just change it at one place. So for example, if we want to run these test cases on test environment, then maybe there's an environment variable and we just change it to test or to UAT or to production, and that's all what we have to change, rather than just changing all the details and then ending up our test to be failed. Or the other case what they have mentioned is that we can use the test stubs, because that way then we don't have that kind of issue when we are running our test automation code on different environments. At the end, the conclusion. The more success factors that are met, the more likely the test automation project will succeed. Okay, so now we have gone through various success factors that contributes to the success of a project and which are really important. And it's necessary that whatever the maximum number of success factors we can factor in when we are planning for automation, it ensures that the project which we are delivering will be successful as well. However, not all factors are required, and in practice rarely are all factors met. So though it's important that we are able to use as many success factors as from the list which we have already gone through today, but it's not necessary that we have to take into account all the factors. It's not important that it will vary from project to project. So it might be that in few projects we don't need to take into account all the success factors, or maybe it's not possible to implement all the success factors, and that's why in practice it's really all factors are met. So we just need to make sure that as many as we can apply to our project for the test automation for that project, it's good. Before starting the test automation project, it is important to analyze the chance of success for the project by considering the factors in place and the factors missing, keeping risk of the chosen approach in mind as well as the project context. Okay, so each project is different, its context is different. So that's why when we are coming up with any kind of test automation approach, the strategy, its automation framework, what would be the architecture of that, it's very important that we analyze it in the beginning and then see that what are the chances for the success factors which we have taken into account can be contributing to the success of the project, and how many factors are in place, how many are not, and the ones which are not, what are the risks associated with that. Because if there are high risks and we say that okay, no, we can't just go ahead with it, we definitely need it, then what we need to do in order to make sure that those missing success factors are implemented. Once the TAA is in place, it is important to investigate which items are missing or still need work. Okay, so once we have the test automation architecture, then it will be easy to identify that which items we have, like which success factors we have and which we are still missing, but we do need it for our project. So it will be easy to identify, and then we can work on it, that okay, that how we can make sure that those success factors can also be met for our specific project. Okay, so with this one, we have come to the end of our first module and also to the end of this session. If you have any questions, please leave your question in the comments, or you can ask me in the group as well. The link to the group is given over here. I will also leave it in the description of this video. If you find today's video useful, then please like it and also consider to subscribe so that you are notified of the future uploads as well. So take care of yourself, and I will see you in the next session.